1.
How do you do, everyone? Welcome to your Friday afternoon lunch and learn from Improving. My name is Tim Rayburn, and today we're going to be discussing the future of the .NET framework, the road ahead, and what it means for you. So I invite you to settle back. We'll have a point for Q&A late in the session, and so you can either ask your questions in the Q&A feature before it gets to that point, and then my producer Michael will forward them on at that point, or you can hold them to the end, and I'll have a point where I just specifically direct you to enter them at that point as well. So for those who do not know me, my name is Tim Rayburn. I am a 11-time Microsoft MVP. I'm a vice president of consulting with Improving Enterprises, and I am a technical author, something of a barbecue fanatic, and an all-around geek's geek. I love all things .NET. I have been doing .NET for the vast majority of my career at this point, and I'm really looking forward to what we have coming up in the next little bit. So with that, let's go ahead and dig into that. So our agenda today is fairly simple. We're going to talk first about the future of the .NET naming, because as we go through this, it will be very important to be able to distinguish the 3 different phases of .NET's naming. And then we're going to go into an introduction to what .NET 5 is. We're going to talk a little bit about NuGet and package management as it relates to the new world that we'll be in. And then we're going to have some closing comments. So with that, let's go ahead and dig in to the future of .NET naming. So way back in 2001, there was the .NET framework, and we had the .NET framework come into existence, and it has served us remarkably well for 20 years. We went from version 1.0 to 1.1, etc., to now 4.8. And the .NET framework through this whole time was a framework of tools that really was targeted at the Windows operating system. There was a very successful open source project named the Mono project that had replicated the framework onto Linux, but until very recently, that was completely separate from Microsoft's implementation of the .NET framework. Now, a few years ago, Microsoft decided that they needed to start forging a new path, one where they could have a lighter weight framework, because the full .NET frameworks library at that point, the install was getting into the hundreds of megabytes just to be able to load the basic virtual machine. And so Microsoft set out and they said, let's talk about a slimmed down version of the .NET framework. And we're going to call that .NET Core. So .NET Core released, and it came alongside the .NET framework, and it was an alternative, but it wasn't a replacement. They were very clear at the messaging of the time that their goal was never to be a full replacement for the .NET framework. It was meant to be an option for workloads that didn't require, graphical UI rendering like WPF or WinForms. They weren't going to handle vast majorities of what the framework used to support. So they came up with .NET Core, and as of the end of last year, we have arrived at .NET Core 3.1. Now, you'll see I've had links on the side here. These go to the long-term support policies for each of these frameworks, and we'll talk a little bit more about that later. But those long-term support policies are going to be important to you, because I imagine most of you are .NET developers. Most of you have code in production, perhaps that is using the full .NET framework, perhaps that is using .NET Core, and you're really how long you can expect long-term support on that, especially since we're about to talk about something new, is going to be very important. So I would encourage you to go look at that and factor that into your plans as you talk about future adoption. Now, the future ahead is now .NET 5. Now, please note, no framework. This is not the .NET Framework 5. This is also .NET, not .NET Core 5, though it is the inheritor of the core line of development. We are simply going to be at .NET 5. And so today we're going to be talking about what does that new world look like. But before we do, let's spend a couple of moments talking about version numbers. So this will be the successor to .NET 3. Or .NET Core 3.1. .NET Core 3.1, direct jump to .NET 5. Yeah, that's so that we don't get confused with the fact that the full .NET framework was at version 4.8, and .NET 5 is also the logical successor of the .NET framework. So we are, despite staying on sort of the basis of the core runtime, and that this is the inheritor and new version of that, we are skipping a version number and going straight to .NET 5 in order to avoid confusion with .NET 4.0 being different than .NET Framework 4.0. So there is no .NET 4.0, there is simply .NET 5.0, and so here comes .NET 5. So let's talk a little bit about .NET 5. So Microsoft's vision for .NET 5 is a unified platform. It's one that this runtime, this .NET 5 runtime, will be capable of running and being used to compile and deploy applications everywhere. It will continue to do thick client applications like WPF and WinForms, just as the full .NET framework has today. It will continue to support your ASP.NET workloads. So for everyone who is doing websites and web APIs built on ASP.NET, .NET 5 is going to be there and be there for you. It will continue to support Azure. It will continue to support the Xamarin model of development onto both iOS and Android. It will support gaming and deployment into the Unity environments, as well as onto Xbox. It will do work for the Internet of Things and get down super small and run on ARM processors. And then it will also be the runtime beneath all of the AI work. Despite all of these wildly different workloads, their tooling, the hope is that the tooling will remain largely consistent as well. You will be able to develop for all of those workflows in full Visual Studio. You will be able to develop for all of those workloads in Visual Studio for Mac. And then as well, if you don't want the full sort of massively robust IDE, you can take the more slimmed down Visual Studio Code and the command line interfaces. So last year, Microsoft announced their plan for upcoming releases of .NET. And I'm going to get my camera out of the way to just let you fully take in this picture. So they said in July of 2019, they were going to release the .NET Core 3.0 RC, and in September, they were going to do 3's GA. And they did both of those things. But this is super important because a lot of you likely rushed to make sure that you were supporting .NET 3, and that's great. But .NET Core 3 was not a long-term support release. The long-term support release was actually .NET Core 3.1 that released at the end of last year. That was the one where they're like, we've hammered out the bugs, we're willing to support this for several more years. And so if you're running on the .NET Core 3.0 runtime in production, you actually are right up against the time period where support is available for that. And I would encourage you to look in your support plans to make sure you are for your server environments, for your production environments, you're making sure that you're in alignment with staying on long-term support releases, or that if you are on something that is simply a general availability release, that as soon as a more stable long-term support release is available, that you move that way. So today we have .NET Core 3.1 as our long-term support release. In November of this year, we expect to see .NET 5.0. All of that wonderful goodness that we were just talking about finally released into general availability. But it is also worthy of note, that will not be a long-term support release. That will be your chance to start stepping in and adopting. You can certainly, it is general availability. You can go to production with those workloads, but you should have your eye on the following November, in November of 2021, when Microsoft expects to put out .NET 6.0, which will be a long-term support release for .NET. And at that point, you will start seeing that Microsoft expects an annual cadence of every November, they are going to release a new version of the .NET runtime, and that every single time that they do that, they will be alternating between simple general availability and long-term support. So it will be your even-numbered .NET releases, 6, 8, 10, 12, that will be your long-term support releases. This is nice. It slows down some of the crazy rapid advancement we've seen in the last several years to give us a more predictable release schedule, one that we can plan for, that we can schedule for, but means that we should be aware of the fact that long-term support only happens every other year. And so at the very least, if we adopt .NET 5 and put it into our production environments, that the following November, we should be looking to move that to the .NET 6.0 runtime in order to enable long-term support. Okay, so what are we doing in .NET 5 that's going to make all of this better? So at this point, there are several things that Microsoft is trying to do. They want this single unified runtime, regardless of what architecture you're running on, what processor architecture, or what devices you're targeting. They want it all to be coming through .NET 5. They want to grab the best of .NET Core, the full .NET framework, Xamarin, and Mono, and bring it all together. And they want to build that product out of a single code base that is developed in open source and that they can work and expand together over the next several years. So because .NET 5 descends from .NET Core 3.0 and that .NET Core line, several things will remain the same. And that's important to remember, especially if you are currently on the .NET framework and not on .NET Core. Here are some excellent reasons that you might want to look at adopting onto the .NET 5 ecosystem. You're going to have open source development, community oriented on GitHub. You're going to see a very high performance runtime. And then they're going to leverage platform specific capabilities so that they can continue to give you WinForms, WPF, and other native things, native bindings, including native bindings like how Xamarin has adapted to allow Android and iOS. If you live in the world of the full .NET framework today, personally, for me, the one right here is probably my #1 favorite reason for being on .NET Core, which is the small project files. Getting rid of project files that listed every single file that is in your project is wonderful, so that adding a new file to disk does not require a change to the CS proj as well, or the VB proj as well. All right, and then capable command line interface and tooling, as we have previously discussed. So what .NET 5 will be new in that you will have more runtime environments. You'll have Java interoperability available on all the platforms, which is something that they're borrowing out of the Mono runtime. You're going to have Objective-C and Swift interoperability supported where it is relevant. And then the the CoreFX, the core runtime framework inside of .NET, is going to be extended to support static compilation. So let's talk about that one a little bit, shall we? So I'm going to jump ahead a few slides. We have lived in a world of just-in-time compilation if you are a full .NET framework dev, and this is how you have approached life. When you compile your code, it compiles to the IL, the intermediary language, and then that IL is turned into assembly just in time. That jitting process literally happens on a method by method basis when there is a need for the code in question. And that's wonderful, but it's not always the world's most performant thing. And it doesn't work in environments where that sort of at the moment compilation isn't available. So one of the things that we get out of Xamarin's experience and Mono's experience on iOS and Android, specifically iOS, is AOT, which is full ahead of time compilation. The ability to come in and say, I know what processor I'm going to be running on. I know what platform I'm going to be running on. And I want to get rid of all JIT and startup delays. So I'm going to go to a full compilation of this and produce a .NET-based assembly that is 100% compiled to assembly for that processor architecture and that operating system already. This should provide some remarkable improvements for those who wisely adopt it. But it is definitely a change of how we have thought about working in .NET so far. All right, let's run back a few slides and get some of the stuff that I just skipped by to go there. So as I mentioned, these are your upcoming ship dates. The .NET 5 in November of this year. We are already at the .NET 3.1 time period, and we will continue to see servicing releases of that as there is a need for security or otherwise to keep things performant. So the other thing that if you have not spent a lot of time already in the world of .NET Core that you may not have a lot of familiarity with yet, but is super important as we move forward, is the concept of .NET Standard. So we've had a couple of false starts with portable class libraries and otherwise in an attempt to say, how do I live into the write once, run anywhere when the frameworks are different on every machine? Where what amount of the framework was available for me on an Android environment is different than for iOS, is different for an ARM IoT device, is yet different for .NET Core, and yet more different for the full .NET framework. So how do we address this complexity? How do we address this in a reasonable way? And that's what .NET Standard was born out of to answer. Now, we have been in the realm of .NET Core, been working on .NET Standard for a while now. And so when .NET Standard 1.0 was dropped, it was the surface area that is of the framework that is exposed in .NET Standard 1.0 is very small. There are very few libraries that can be produced who can say, I can be Net Standard 1.0. If they're just pure calculations, if they're objects with methods that simply move some data around and perform simple compilations, it is entirely possible Net Standard 1.0 will be capable of it. But then incrementally, .NET Standard 1.0 to 1.1 and so on up the line to eventually we see .NET Standard 2.0 and .NET Standard 2.1. Now this chart that is up on the screen gives you a feel for which frameworks that you might be running on support which versions of .NET Standard. So for instance, we can see in this version that we have the .NET Framework 4.5 supports 1.0 and 1.1, But if you want to get to .NET Standard 2.0, you actually have to get all the way up to 4.6.1. And if you want 2.1, this actually was pulled off of a slightly older article, you can get that in the 4.7 releases of the .NET framework. Likewise, you can see which versions of the Mono runtime support all of these things, etc. What's interesting here is that we have gotten to the point where .NET Standard 2.1, the surface area that is defined by that level of support, is remarkably robust. It will let you do reflection inside of .NET Standard library. That .NET Standard library can be loaded into a .NET Core 3 runtime. That .NET Standard library could be loaded into a 4.7 .NET Framework library. Likewise, all of the other versions that are listed there. This, if you want to get a feel for how Microsoft is setting this future, how we're enabling us to go forward, .NET Standard is a very important part of this. I would encourage you, as you're looking at your libraries and looking at how you're architecting your solutions, .NET Standard is not a replacement for, am I running a console app or am I running an ASP.NET web app? Like, those things are going to be, websites or console executables or otherwise in your particular runtime. So I might be writing a .NET Core console application, let's say, and I'm writing that in .NET Core 3.0. But as I then go to write my business logic or other libraries, it is very important that those ideally target not .NET Core alone, but for maximum interoperability, for producing an environment where your library is going to be most useful to the rest of your enterprises or organizations on a long-term basis. You want those class libraries to be targeting .NET Standard and to come in and say, we don't care about core, we don't care about framework, we don't care about .NET 5. We care about the fact that we're .NET Standard 2.1, and that gives us enough robustness to then be loaded into any of these other environments. So that's standardization is what is provided by .NET Standard. Now, if several of you who are working on the .NET framework today may have looked at .NET Core in the past and gone, oh, well, I'd love to go adopt .NET Core. But then when you start looking at the realities of that, it wasn't that easy. For instance, you probably were using Entity Framework for data access. And Entity Framework had a successor called Entity Framework Core. And Entity Framework Core is continuing to expand and grow and become more and more capable with every single release. But the reality is that the early versions of .NET or Entity Framework Core simply were not a one-for-one replacement for the original Entity Framework 6. So a lot of people were sort of stuck and going, unless I want to completely revisit my my data access layer, I'm kind of stuck on staying on .NET Framework at the current time. Well, in September of last year, Microsoft really stepped up and said, no, we've got you. Because they came in and said, we have a new release of Entity Framework, which is Entity Framework 6.3, and that library supported .NET Standard 2.1. So suddenly that meant that if you were interested in taking your existing code base and saying, hey, I want to be able to run this in an environment where I'm going to be on the Mono runtime, and I'm going to be on at least Mono 6.4, then Entity Framework 6.3 could continue to load, to connect to SQL Server for you, and do all of the data access that you need it to. Now, to be clear, Microsoft still encourages you to look at the an eventual transition to the world of Entity Framework Core, but they are also realistic that given all other things being equal, this was a step that was necessary for a lot of organizations to be able to step through this process, to at least move only one thing at a time, to step onto .NET Core or perhaps .NET 5, and to do that without having to completely revisit their data access layer at the same time. And then at a future release, after you're stable on the new runtime, you could also look at going from Entity Framework to Entity Framework Core. So these are several important things that come with .NET Standard. Now, we've talked about ahead of time compilation at this point. There's one last thing that we should really talk about here, and that is the web section of this graphic was horribly missing a very important development that Microsoft has underway. If you are looking at the world of the modern web today, one of the most exciting things going on is the concept of WebAssembly. It is the concept of being able to write code not in JavaScript that will take full advantage of the processor capabilities of the box the browser is on, and do so in an agnostic way that doesn't care about the differences between the fact that that browser might be running on Linux or running on Windows or running on Mac. Now, how do we possibly do that? Well, obviously, this concept of a runtime that runs anywhere is very, very similar to that. And so Microsoft has been working on enabling the .NET framework into the world of WebAssembly in a project called Blazor. Blazor is coming along remarkably quickly. I encourage you to go look at these libraries, and you get to live in a world where you can write full C# code that will be executed in the browser. Now, you don't have access to everything. You can't go plumbing people's file systems there. You are in a sandboxed environment, but you are writing in a single language. You start getting rid of the dissonance that can occur when you're trying to mentally walk through okay, here's my JavaScript and I'm doing these things. Now suddenly I'm server side. Now I'm back to C# and I'm constantly having to flip between those. You can provide a more uniform look to how you go about doing that. Blazor is absolutely amazing. I encourage you guys to check it out. And it is going to be fully supported in the world of .NET 5. Now we need to talk a little bit about NuGet and package management, because there are some interesting things that NuGet has taken off of the shoulders of the full framework or the full runtime in order to enable this future world. In many ways, what is being accomplished in .NET 5 is truly only capable, or is truly only possible, because of some interesting enhancements that have come down the road for NuGet. So let's take a look at that. Today, in the world of .NET, if I say, hey, I need to go grab some package that is available on NuGet.org, and I'm going to go and install it, I will come up and perhaps say, hey, I need to install Newtonsoft, okay? Because I want to have the Newtonsoft JSON.NET serializer and deserializer. Okay, I can know that I want Newtonsoft and say, I want to install that package. Now, we're all familiar with the fact that today, I don't actually just install that package. I install a particular version of that package. That when I am saying install whatever package is, my package 1.0 here, I am now saying this particular version, I want this particular package of this particular version, and that's what I'm going to take a dependency on in my project. In reality, today, if you are working with any of the current and modern tooling, this is not everything you are saying when you say that. When you say you want a certain package 1.0, you are actually saying 3 more things about that package. You are first also telling it what platform that it's going to run on. That might be Windows, it might be Linux, but it's going to be aware of the package. You're also telling it which architecture you're going to be running on, which is am I deploying to x86 or to ARM or x64? And finally, I'm aware of what framework or which pseudo framework I'm going to be running onto. Is it .NET 4.6, 4.6.1, .NET Core, etc.? These frameworks are also being conveyed. Now, it's important to note, you don't actually say all of this when you install. You simply install the package by the version number. And then when people create NuGet packages, they can create different actual assemblies that answer each of these variants. And they can also do a thing, and this is the one that's going to break some people's minds. They can say, there are versions of these additional things we simply don't support. So, for instance, .NET 5, which says that it wants to run everywhere, and it also says that it wants to support WinForms, for instance. Does that mean that I will be able to write a WinForms application on iOS? Because .NET 5 runs there, and WinForms runs on .NET 5, right? So that should just work. And the answer is nope, because the WinForm NuGet libraries that you will be pulling in to do that are going to be Windows platform only libraries. If you attempt to bring them in and use them when the platform is Linux, you're going to be told, I'm sorry, this package isn't available for this combination of platform architecture and framework. Now, this is how NuGet being able to have this level of refinement, to be able to talk about platform architecture and framework in addition to simply package and version, is how we have been able to go, oh, I can write a NuGet package, and that NuGet package is a new set of Xamarin controls for, say, Xamarin Forms, and it's going to only run on the Xamarin iOS runtime, and it's only going to run because of that on those architectures, because of the fact that that's the only place I intend to support this, and it becomes a NuGet package that is limited to that space. This is how we have managed to thin out the runtime. Remember how I mentioned earlier that there was this concern with how large the .NET framework itself had gotten because of the fact that it had everything. It had all of the rendering engine for WPF. It had all of the rendering engine for WinForms. It had all of ASP.NET Classic, including all of WebForms embedded inside of that runtime. All the supporting libraries were there. With .NET Core and .NET 5, the model has instead been, really, the runtime is only there to answer the most base of base class library needs. And everything else is shifting into NuGet packages. And those NuGet packages are allowed to come in and say, we only run on certain platforms. We only run on certain architectures. We only run on certain frameworks. So this allows Microsoft to take the WinForms libraries, make them a Windows platform only capable set of libraries, because they in turn have dependencies on the Windows APIs, and they simply can't run on other platforms. This level of robustness, though, is important for another reason. If we lived in an ideal world, if we lived in a world where every package maintainer brought a level of scrutiny to this capability that I would like, then this would simply be enough to know that in certain situations, certain packages simply will not load and will not be available for your Linux workloads or your iOS workloads or your Android workloads. But that's not reality. What has begun to emerge, and I don't love it, but it is true, are package maintainers who put out libraries who say, okay, we do all of these things on all of these various frameworks, but they'll ship, for instance, a Windows and a Linux version of that package. And again, you will still simply come in and say, I'm looking for my package 1.0, and then the Visual Studio tooling or the .NET tooling of the command line will simply load the appropriate version of platform architecture and framework for you for where you're running in development or where you're going to deploy to eventually. But there are package maintainers out there who have begun to ship libraries that will do this, but then when a particular supporting API is not available on that particular platform, for instance, let's say an example of they needed a GDI drawing library that is a Windows-only drawing library, and they've said that this thing can be loaded on Linux, they will simply make it so that their compiled form for Linux throws a not implemented exception off of those methods. Don't love this at all, but you need to be aware that that exists. Just because of the fact that a package says that it supports all of these things doesn't mean you don't have to test it, because of the fact that each permutation of platform architecture and framework needs to be tested to make certain that all of your libraries continue to work. If this complexity is a wonderful tool, but like most powerful tools, it can be abused. So learn and support those people who write libraries correctly and do not run into these situations where they simply throw not implemented. The best thing that we can do is vote with our feet when it comes to package maintainers and make sure that we encourage them to properly use the capabilities of the NuGet platform. But then realize that since this is going to be a problem, we must test, and test on the appropriate architecture. Simply, if you're deving for a world where my Windows box is running Visual Studio and that's where I'm doing the bulk of my code, but I expect to deploy onto a Linux Docker image for actual production deployment, you should be making sure that you actually test on that Linux runtime, because it could affect how some of your packages load. I don't want to scare you off. NuGet is still a wonderfully powerful tool, and I think that the community is simply learning how to properly use all these capabilities. But as it stands today, this is definitely a cautionary note that you need to test to make sure that you're in a good spot. All right, we will shortly be getting to a point where I will be closing this up. So if you have any questions about this that you want to ask, now is an excellent time to go ahead and jump into the Q&A section here on this Teams meeting and ask them. And at that point, in a few moments, Michael will give those voice onto the feed and we'll be able to try to answer those for you. In the meantime, let me give you some closing comments. Improving is doing these virtual lunch and learns every Friday for at least the next 12 Fridays. This week, I've been talking about the future of the .NET framework. Next week, we're going to have Michael Perry coming in and talking about ACID 2.0, a new set of promises that a database can keep in a world of increasingly distributed systems. And so here's Michael's abstract. Michael is great, and I would strongly encourage you to plan to come back next Friday, same time block, 12 to 1 Central Time US, to hear Michael talk a little bit about the world of ACID 2.0 and what it can do for you in that in the world of databases. Now, with that said, given some time for questions to flow in, Michael, do we have any questions that have come in?
Hey, Tim, can you hear me?
I can.
All right. The first question I have for you is, do you have any recommended patterns on a smooth migration into .NET 4.5, 4.8, or 3.1 or later?
So moving into from .NET Framework 4.5 and on into the world of .NET 5 and how to smooth that transition?
That's correct.
Okay, with that question, yeah, my recommendation would be start with your class libraries and start looking at .NET Standard. Don't start with your executables. Go through and start the migration process for all of your various class libraries that are used inside of your project, and start moving them to an appropriate version of a .NET Standard library. This will make you deal with what of my various dependencies in turn already support .NET Standard. And the good news is that the open source community has been wildly adopting .NET Standard. So you will find that almost every library you could possibly want fully supports .NET Standard today. But that will allow you, before you look at moving off of runtime, to simply say, let's look at all of the class libraries we have and start an iterative migration on each of those. And you can take each one in turn, and just because it goes .NET Standard doesn't mean that the other libraries that depend on it immediately have to as well. So it is small, iterative, and lets you take these in small bites. And then once you have completed a full set of your libraries and all of those are in .NET Standard, then look at making the jump from one version of the runtime to another version of the runtime. So for instance, at that point, jump from .NET Framework 4.5 to .NET Core 3.1, for instance, today for a website, if that is capable, or .NET 5 later this year once you're doing it. But if you start that process now, you can, even if you need full .NET 5, if you're deploying a WinForms application, and as such, you need the .NET 5 release to truly be able to do that inside of the new world, you can start the .NET Standard work now. There's no reason that you can't work on getting onto .NET Standard for all your class libraries, and then only once we have a general availability release of .NET 5, then look at upgrading your actual application to that at that point.
All right, Tim, I got another question for you here. And this is centering around single page applications versus Blazor. Do you think Microsoft is wanting to pivot away from SPAs in favor of something like Blazor, or what do you think is going to happen in the ecosystem there?
I think that much like when we saw single page applications enter onto the scene to begin with, and suddenly they started to catch like wildfire, and I've had a joke for several years now that if I go to lunch and come back, there will be 2 new JavaScript libraries released in that amount of time. While it took us several years to begin to ease down and get into a place where, for the most part, you have Angular, React, maybe Vue doing a little bit of work, and that's sort of become the primary set of frameworks that have settled in SPA. I think we're about to kick off another round of that, and I think we're going to see a new set of capabilities coming. But I don't think it's just Microsoft. I believe Blazor is meeting the Microsoft community with what WebAssembly is capable of. But I expect to fully see a world where even Angular and the other projects are also going to try to move forward, because of the fact that WebAssembly will give them a future world where they can get more performance out of that browser than they were previously capable of by standing on top of the JavaScript runtime. Now, what exact form that takes for each of those projects, I don't know. Will one of those existing projects be the person who comes out on top, or the project that comes out on top, or will it be something else completely new? I unfortunately don't have a good crystal ball that's going to tell me that. I certainly think that if you had asked me when I first saw Angular 1.0, did I believe that this somewhat kludgy, weird framework was actually going to dethrone the king of JavaScript libraries of the time in jQuery, I would have told you there's no way that's happening. And I would have been horribly wrong. So I think we're going to have to see what the inventive minds of our open source community come up with, and whether or not it's Blazor or whether or not it's another one of these WebAssembly-based libraries. I do think that the world of single-page applications is definitely about to go through yet another revolutionary time period as we move forward.
Thank you, Tim. Another question I have is, some of my colleagues decided to use ADO.NET instead of EF Core, regardless of the version. They believe ADO.NET may have better performance. Do you have any thoughts on that and recommendations to move forward?
I think that at the end of the day, it is very hard to argue that if I go to the base library that underlies something and write directly against that I am not capable of getting more performance out of that than I am out of a library that helps, like what is going on inside of Entity Framework Core. On the other hand, you have to balance pure runtime performance versus development time. I think that if you're writing directly against ADO.NET, I would suspect you are spending a lot more time writing your data access layer than you would be if you had a lot of the help that comes for doing that with Entity Framework Core. So at the end of the day, classic consultant answer, it depends. And it really comes down to, in this balancing of things between development time and runtime performance, what is most important in your project? The reality is we have, for most projects, long time ago, moved away from it's all about runtime performance. There are very few projects that I run into where every millisecond, every nanosecond counts is the world that they're living in today. And so if the business owners who are behind that were given an informed decision that said, hey, we could say 50% reduce the time that it takes us to write our data access layer in exchange for a slight increase in the processor needs of the project in production. I believe that given how cheap processing is in production environments, most business owners would choose to say, nope, we'll take that hit and we'll take the operational cost over the cost to get the project developed to begin with. And so it really has to, there is not a full out, there's one right answer to this, as much as it is be realistic, ask the hard questions. Is the gain in performance worth the cost in time that it costs you to increase development? And if the answer is yes, then you've made the right decision. If the answer is no, then perhaps it's time to look at Entity Framework Core and see where it can help you. I will add to that, these don't have to be all or nothing choices. And I think that we often as programmers get into this fallacy of the fact that that is an all or nothing choice. If you were to do most of your data access layer with Entity Framework Core, and then you run into something that is causing you a performance bottleneck in production, at that point, extracting that piece and saying, we're going to implement it specifically in ADO.NET because we know we have measured and we know this is causing us performance issues, that's probably the pragmatic approach.
Thank you, Tim. My next question is, given the complexities of runtime version requirements for Azure services such as Azure Functions, what are testing tools available to test each of app services against the framework, especially when you're using VS Code?
Yeah, that is not a supremely easy thing to answer because you've mixed a variety of things there. You're running into functions where you have very limited capabilities as to how much you can play with runtime. And you don't have an easy way to completely host an identical environment locally. I think that if I were wandering into this space, I would make sure that I have a solid set of integration tests to help make this work for me. but I don't believe that that I'm aware of a silver bullet that just answers that, who says, I'm going to make it easy to know that it works across all of these variety of runtimes, etc. This is one of those moments where, unfortunately, it's just going to be some hard work. I would probably actually have it deployed into the appropriate environments with the appropriate runtimes and focus on integration tests to make sure that you're covered, and not assume that local development is going to be able to perfectly reproduce that.
Thank you, Tim. I have a follow-up question on Blazor. Someone has commented, how is Blazor not going to be the next Silverlight? Can we really depend on the support?
Oh, that's cake easy to answer. The answer to that is that what Blazor is standing on top of is a openly accepted standard. Silverlight died because of the fact that there was no accepted way to go about and broadly reach this. Also, Silverlight was unfortunately poorly timed into the market with regards to a revolutionary change that happened in the world of the web just as Silverlight was getting traction. We decided that we wanted richer UIs on the web, and we were totally in, and Silverlight looked amazing and was really, really compelling, but it was built on a browser plugin structure. And then all of a sudden, the iPhone came out. And nearly overnight, half of the web traffic moved to these wonderful little devices that look like this. That change and the hard and fast opinion of the mobile operating system developers who said, we're not supporting the plugin structure, meant that Silverlight pretty much died. To be clear, so did Flash, right? That entire ecosystem crumbled. WebAssembly is built on an assumed mobile world. It is supported in all of the mobile browsers today. And so what Blazor is standing on the shoulders of in WebAssembly is already a mobile-friendly, capable set of routines that allow us to have that assurity that Microsoft's flavor of that in Blazor is not about to suffer the same fate. And I would say, if you look at the world of IBM and Google and a variety of others, there are lots of people looking at saying, what interesting and fascinating things can we do with WebAssembly? So this is definitely the future of where the web is going. It may not be Blazor. It may not be a library based on Blazor, but I am fairly certain that the future of web application development and what happens inside the browser is going to heavily leverage WebAssembly in some way, shape, or form. And let's hope that Blazor is a compelling option for that.
Thank you for the reassurance, Tim. I think our last question is going to be from Alan. If we were looking to move applications from the .NET Framework 4.7 to Core 3.1 in the next 12 months, do you think we should delay that plan until .NET 5 is available, or should we get going now?
No, I would get going now. I think that if you're looking at a set of applications where .NET Core 3.1 is capable of it, I would definitely be going that way. I would remind you that 3.1 is the long-term support release, and that we won't be in another long-term support release until November 2021 and .NET 6 before we hit another long-term support. So if you're moving a web app or something that .NET Core 3.1 is already capable of answering, go that way, start that process. Everything you do there is going to carry you forward as we look at the future versions of .NET.
Awesome. Thank you, Tim. One question did just come in if we're going to have a schedule for our published talks. These talks will be on every Friday around this time at noon. And if you do miss them, we are going to make them available on Improving's YouTube channel shortly.
All right. So I did want to mention as we wrap up here that just yesterday, .NET 5 released their Preview 2. And that was, so we have fresh new bits available to play with. And if you're someone who likes to go play with preview bits and see what's going on and see what's under development, then this is where you can go to get those bits and start playing in that space. And so while the full release is in November, they're making good progress, and they have bits available for you to play with today if you would like. And with that, I thank everybody for your time. And I appreciate you coming, spending some time with us today and learning a little bit about the future of the .NET framework. And look forward to you all returning next week when Michael talks about ACID 2.0.